All this is Dr. Mubin Sayed. Welcome to one more show. I do not know what to call these shows, one more show or something else, but anyways, welcome. Welcome to the cafe. Today, what I want to do is, in addition to our chit chat, I wanted to discuss some potent ways to trigger autophagy and some cares to take when we do autophagy. I see a lot of articles, literature, some backed by good evidence and some not. So today I wanted to actually go through the evidence with you. So let me provide a context for the discussion. We are aware that at least in the more affluent societies, the nutritional levels and the frequency of eating, amount of eating, and then the environmental factors, they play a role in reducing cells cleaning or in inhibiting autophagy. So the thing, I want to make sure that my audio is working. I always get worried. But anyways, what I want to make sure is that we can look at what are the factors that can trigger autophagy. And is it possible that autophagy will not trigger in some individuals? And if that is the case, what are the possibilities to force the autophagy to occur? So right in the beginning, I'll provide a few disclaimers or cares to take. Number one, autophagy is relevant it is a relative aspect to your health. So for example, somebody who is already eating less and they have inflammations, when they do intermittent fasting, they have to measure it to their own body's requirement to see how much they can fast. Similarly, intermittent fasting, for example, can also trigger stress hormones if it is too intense. And those stress hormones can then counter the effect of autophagy. Thirdly, in women, the fasting times have to be adjusted to their monthly cycles, because at various stages of their menstrual cycles and their monthly ovulation cycles, their energy levels may go down, number one. Number two, their need for food or nutrition may increase. And number three, their capability to handle stress may fluctuate. So generally, let me start from this topic. Generally, for women, number one, you have to actually, when you're doing the intermittent fasting, you have to start slow. For example, 12-hour fasting, then slowly reduce the window of eating and increase the window of fasting. Secondly, as you're doing this, check how your monthly cycles are going and if there is any change in them. And that is where you stop if there is a change. Thirdly, some rules, just rules of thumb, you can say, are that during the menstrual time, one should not fast. That can become detrimental to the health of the person, to the woman. After menstruation, that follicular time that is before ovulation, that is a good time for intermittent fasting. The energy levels are up, hormonal levels are great, and the potential to take stresses is better. During ovulation, 2 days, or mostly on average 2 days, intermittent fasting can be done. However, if you skip it, it is better. Then after the ovulation starts the luteal phase, where the uterus starts preparing for the fertilized egg, and then the ovulation has occurred and the ovaries repairing that area from where the ovulation occurred. During this time, a lighter intermittent fasting will be better. And then, of course, the menstrual period again, and so the stopping of the intermittent fasting. Just general uh, thoughts. Then, the other important thing to keep in mind, when we are trying to trigger autophagy, and I'm supposing that you are aware of autophagy. Autophagy is the process of cleaning up the cell trash. I'll actually go over the mechanism in a few minutes, but I want to put those disclaimers out first. When you're trying to trigger autophagy to handle inflammation, chronic inflammation, or the as a preventive method for avoiding outcomes of inflammation, then it may be necessary, if you're not getting the results, then it may be necessary to have more than one interventions that trigger autophagy. So the question becomes why. So imagine I started intermittent fasting, and I wanted to have, the intent was that I would deprive my cells of nutrition for some time, and that would start the autophagic mechanisms, and the cell would start becoming cleaned. However, let's say it's not working. My inflammation is still there. I'm not seeing the results. The reason for that could be that the cell and the nucleus, remember yesterday we talked about the cell getting filled with the trash, misfolded proteins. Those misfolded proteins then interfere with the other proteins' functions. There are a set of proteins that are called post-translational modifiers, or PTMs. And the post-translational modifiers are for many kinds of enzymes. What they mean is post-translational modifier. Translation means to make a protein. Post means afterwards. Modifier means to modify that. What that means is to modify a protein that was just made. Why do we modify a protein? Imagine we made a protein whose job is to, let's say, go and take omega-6 from the cell membrane. Let's say that is phospholipase A2 enzyme. However, we do not want phospholipase A2 to do that function all the time. So what you can do is you can make that enzyme, and then you can pack it into a box so that it does not become functional. And then at some point you release it when you need to. So that packing in the box is called the post-translational modification. There are various ways, for example, phosphates or kinases are activated that can modify a protein temporarily to stop it from functioning. Then when the time is right and when there is a signal for that protein to function, then those modifications are removed, those packings are removed, and the actual thing becomes unmasked or activated, and it can go and do its function. So sometimes the post-translational modifier proteins are not working correctly because of the chaos inside the cell. So in that case, just intermittent fasting may not be able to trigger autophagy because the internal mechanisms are not responding correctly. So in such case, you may have to add more interventions, for example, spermidines or resveratrol or rapamycin or metformin, that would go and help block other modifiers and allow the autophagy to occur. So this is a very important point, because many times I hear from those who listen to my lectures and they say, I tried it and nothing happened. And so one has to see what their intermittent fasting method, they have to see what are they eating when they are eating, how much inflammation did that cause, what they ate, and then also maybe there are post-translational modifiers that are blocking the autophagy from triggering, then you add more intervention. Once you do that, you create combinations of autophagy triggering mechanisms, then as autophagy starts and it starts cleaning up the cell, then you would start recovering from that state, and then normal intermittent fasting can start triggering autophagy as well. So I hope these 2-3 points are clear. And now I'm going to share my screen, and we're going to go over first of all what is the mechanism of autophagy, just a high level, and then various interventions. And I'm using the word intervention because there can be chemical substances, for example, spermidine or metformin, rapamycin. Exercise is a possibility. Heat exposure, cold exposure is a possibility. So they collectively are interventions. So let's do that. And welcome to everyone. So Alexander says, overall life expectancy in countries where we don't have to live autophagy is nearly double. So blue zones have a different life expectancy, of course. Okay, so let's start from here. First of all, let's look at, I wanted to actually read this. This is a disclaimer. Effects of intermittent fasting on the circulating levels and circadian rhythms of hormones. All of these links are in the description. So I want to read this conclusion here. Given that the intermittent fasting could alter both the level and frequency of hormone secretion, decisions on practicing intermittent fasting should take more consideration on potential detrimental consequences versus beneficial effects pertaining to individual health conditions. So how do you then approach intermittent fasting? Of course, whatever I'm going to say here with your doctor's approval and consultation. The way to approach that is, for example, let's say a meal plan is the breakfast and then a snack and a lunch and a snack and a dinner. So the first thing is to remove the snacks. The first thing is to remove any cokes or juices that are taken between the meals. So that would be first level of starting to fast, and it would not cause stress. Then second thing would be to start changing the time of the meal, but you're still taking those meals. And that would also be allowing the body to start adapting to this change. Third will be then to skip a meal. And I've done a discussion about this before. I think it's about a year ago. The third will be to start skipping a meal and adjust the other 2 meals time, that while you're awake, these 2 meals are making you plenty happy. And then you can start doing caloric restriction and carbohydrate restriction and change the meal plan. You can do one more thing, which is the fasting mimicking diet. This is another fancy name for plant-based diet. It's not necessary that you become fully plant-based, but you could make one meal more plant-based or more fluff meal, a meal which contains things that may not give as much energy as a regular meal will, but still your body would think that there is food in the stomach and the body is satiated and the stress hormones will not trigger that much. Meaning intermittent fasting has shown to be beneficial. You can just approach it from your beginning point to the intermittent fasting point with a planful method. Okay, so first of all now is the overview of molecular mechanisms of autophagy. And I'm not going to go into the whole detail. I want to explain this diagram, especially this part of it. And I'm going to do that with my diagrams. I'm also looking at the comments. Sorry about that. Sigrid, get well soon. Okay, so here. So we did this discussion yesterday on Dr. Bean Medical Lectures channel. that how misfolded proteins start aggregating in a cell. Here we are going to talk about something else. Imagine that there is this pile of misfolded proteins, and the body has tried to take care of it through ubiquitination. So there are ubiquitination flags on it. This pile has been marked to be cleared out, but somehow the ubiquitination mechanism is not able to clear it out. The body or the cell is expecting that at least autophagy mechanism will become activated. However, that mechanism does not become activated because there is a molecular pathway called TOR pathway. This pathway is called mTOR, mammalian target of rapamycin. Why is it called that way? This pathway was first found when scientists were using rapamycin for other reasons on a cell. And they found that this particular protein started becoming inhibited with rapamycin's presence, and a new mechanism happened. Autophagy started. So they named this protein and this pathway. This protein is called mTOR, or mammalian target of rapamycin. And this protein, normally when we are well fed, when our nutritional status is good, when our oxygen levels are good, when we are not as much stressed, when we have plenty of amino acids, carbohydrates, and lipids available, then this mTOR impairs or inhibits the proteins. So let's say there are proteins here. These proteins' function is to do autophagy. These are worker proteins. We should give them some eyes. They are good proteins. They're worker proteins. Their job is to create autophagy or autophagosome, and I'll explain that in a second. Their job is to do autophagy. However, mTOR, when present and active, it blocks them. So normally in medical sciences, when we talk about something is blocking another thing, we put this little line over here. This line means that mTOR is blocking these enzymes. So let me just say these are the autophagy. I'm lumping them all together. Autophagy enzymes. Their job is to do autophagy. And now they are blocked by mTOR. And why are they blocked by mTOR? mTOR acts as a sensor for nutrition in the cell. So the carbs, amino acids, lipids, when they're present in ample amounts, mTOR says, you know what? No need for autophagy, no need to scour around the cell to go find nutritional substances. However, when there is nutritional deprivation, when there is less nutrition available, then what happens is that the mTOR, because it is a signal, mTOR enzyme system is blocked. So less nutrition leads to blockade of mTOR. When mTOR is blocked, of course, now it is not blocking the autophagy mechanisms, and the autophagy proteins will become active. Now, what will these proteins do? They will start creating something that we say autophagosome. So they'll actually, in the literature, this is called like a cup-like shape, which will then start growing into a sphere. So when it is in the form of a cup, imagine that you are at a beach and you have a little cup and you plow that into the sand, and then you put a lid on that cup. Now you have trapped and captured some sand in that cup. This is what autophagy does. So initially there is this cup-shaped structure that is formed, that is created. That structure would slowly continue to grow, and it would pinch off whatever part of the cytoplasm. Cytoplasm means the part of the cell's environment outside of the nucleus and inside of the membranes. Part of the cytoplasm is is eaten away. Now that part will contain some of the ubiquitinated proteins as well. Remember that these were marked for ubiquitination. So they have markers on them, but they were not ubiquitinated because the ubiquitination system was not able to degrade them. So now this little sphere that completed has pinched away, has bitten away this part of the cytoplasm. Now we have a piece of trash in this little sphere. This sphere is then dragged in the cell to fuse with another vacuole meaning another bag that contains various kind of enzymes that can degrade whatever you put in front of them. So these enzymes here, this vacuole is called lysosome, and as the name says, lyso is from lysis is from breaking down something, dissolving something. If you put something in acid, that thing would be dissolved away, right? So these are proteosomes, proteases, DNases, RNases, other enzymes that can pick up anything you put in front of them and they can destroy it. So this phagosome is then fused with the lysosome and we develop an autophagosome. This is where the action happens and the enzymes will now attack whatever debris was captured and they would degrade that debris to their smallest parts and release that in the environment for the cell to use that to make energy. So far so good. Any issues with this? So the question now that has to be in our mind, and let me pose that question to you so that you start thinking about it. What is in your cell that autophagy is not triggered? What are some of the factors that cause autophagy not to happen? Of course, the very first one, I think you would answer with that, is that plentiful nutrition. And plentiful nutrition does not just mean lots of carbs. Carbs, amino acids that are coming from meats or other proteins, whichever protein is plant-based or meat-based, and lipids. When these are plentiful, that turns off the mTOR pathway, or that, I should not say turn off, that keeps the mTOR pathway going so that the autophagy stays blocked. That is one. Another pathway is called AMPK pathway. AMP kinase. What does that mean? So if you see the name here, AMP, adenosine monophosphate. Remember, the energy that we make in our cell is called adenosine triphosphate. If we attach 3 phosphates to adenosine, that is energy packet. When there is less energy, then adenosine does not have 3 phosphates attached to it. It has 2 phosphates and it is called adenosine diphosphate. And then it has 1 phosphate and that is called adenosine monophosphate. This phosphate bond is the energy packet. So when we have more adenosine monophosphates, that means we have less energy. Because if we had more energy, we will have ATP instead of AMP. Or the relative balance is different. More ATP, less AMP. When the AMP is more, that means our cell is deprived of energy and AMPK pathway would become triggered and it would trigger the autophagy. So this is another mechanism. Then there are mechanisms which are, let's say, external signals. For example, if the growth hormone is acting on this cell, growth hormone, then the cell would assume that the growth hormone is here to tell me that, hey, please grow. That means it is only here because there is energy for me to grow as well. So why should I do autophagy? So growth hormone, for example, would turn off autophagy. Similarly, presence of insulin. According to our cells, they wrote an article to us. According to our cells, presence of insulin at their door means there is a lot of glucose present in the environment. And if the insulin is there, that means glucose is going to come in soon as well. That means we are plentifully nourished. That means we do not need autophagy. Now, this is another problem, though, that in our latest modern lifestyle, when we take foods that are ultra processed, that are heat processed, that have irritants in them, those irritants can cause beta cells to release insulin without carbohydrate present, or without even the amounts of carbohydrates needed to release a specific amount. Insulin release increases from the irritated, agitated beta cells. That insulin, when comes to this cell, the cell would assume there is glucose in the environment. Cell doesn't know that you ate something that was not healthy and had irritants in them and had ultra processed things in them, those things that cause advanced glycation end products, those things that produced a lot of reactive oxygen species. Cell doesn't know that. Cell just knows that there is insulin at the door. That means I have a lot of glucose coming in. I do not need to do autophagy. So these are hormonal examples that can turn off autophagy. Similarly, we know interleukin 10, it is released by T helper 2 cells from the immune system. When those cells are active, they release interleukin 10, which can turn off autophagy in the cells. Why? Well, when we have active immune system working, that is not the time to start scouring around in the home to say, where can I find some food? That is a time to be alert and find nutrition from the environment and go on a war. So these signals can alter the behavior of autophagy proteins. And they don't directly come in and work on these proteins. These are a number of proteins. These pathways can work through other proteins. They can activate the proteins which can then go and block autophagy. They can activate the proteins, then they can go and activate mTOR, and mTOR in turn will block autophagy. These are called post-translational modifications. Make sense? So now let me add some pathological reasons for autophagy not to trigger. So I'm going to go here, and let's say here is a cell of a person. Let's say it is my cell. So don't give your example. Let's say it is my cell. I am 50 plus. And imagine that I've been eating whatever carbohydrates and other meals and so on. And what I have done is I have created a lot of trash in my cells. And for those who are listening to these talks for the first time from me, the trash over here are misfolded protein, and then they're tangles. Misfolded proteins, which then tangle up, and they come in your way. It is just like if you go out on a street and the street is all broken and there is repair work that is happening and there is debris everywhere and potholes and the dust and the dirt. Will you be able to drive your car correctly? Or imagine if my room here is up to my neck with trash. Will I be able to perform my functions correctly? So let's say that is the situation of my cells at 50 plus year of age because of my previous ways of life. When that happens, we discussed this yesterday, that can cause actually DNA repair problems. That means the DNA might accumulate mutations which would then not get repaired correctly. And the one result of that will be production of misfolded proteins. Now we do not need reactive oxygen species to come and do that, but instead the DNA is the genes themselves have become modified, and now they're producing bad proteins. They're producing dysfunctional proteins. Now imagine that this protein over here is responsible for autophagy. But when it is produced, it is misformed already. Now you are doing intermittent fasting, and now you're hoping that somehow this protein will work. But this protein is not working. Why isn't it working? Because it is misfolded. So now we are stuck. When this happens, our next course of action is to try to trigger autophagy through more than one pathways. So as I discussed these pathways over here, these were not just to tell you that I know these pathways. These were to present to you that there can be multiple factors that can trigger or that can block autophagy. And when one pathway isn't working, then you can trigger through other pathways. Eventually, you want the autophagy to start so that then as the things would start becoming clearer and as the repairs would resume, then even the intermittent fasting can trigger autophagy. So then if the question is in your mind that what else can we do? The point is we have to do something that doesn't just go through the intermittent fasting pathway. Examples, we can take Spermidine with it, with intermittent fasting. Spermidine activates the autophagy through a deeper action into the pathway. So imagine that the mTOR pathway, here is the mTOR, and this protein blocks the autophagy proteins, and these are set of autophagy proteins, many of them. They all get activated when they are released from mTOR, and eventually there is this protein that becomes activated, which then causes autophagy. So it is possible that Spermidine, instead of acting here, where intermittent fasting acts, Spermidine could act here and bypass all of this part of the pathway. Or if we are exercising, we might act here and bypass this pathway. So in the beginning, when you are not responding to autophagy or to things that you're doing for triggering autophagy, you may have to create a combination. So the discussion today is to show you what are various possibilities so that you can create the combination with your doctor's advice and consultation. So OPME says, how can you reconcile hunter-gatherer diet to modern industrial diets? It's not possible. You're correct. It's not possible. The modern industrial diets that take anything and take it to, number one, they make it more flavorful so that we can like it and we become addicted to it. And number two, they produce it at a large scale. So they pass it through high temperatures and industrial machines and then packaging and preservations and coloring. That can never rise up to the healthy levels of hunter-gatherer diets. So you're very correct. So we will have to then figure out our ways to counter that by doing things to trigger autophagy. Or if I said, by targeting inflammation that it does not occur, or it is reduced, or it is controlled. And the best thing to do that is not letting these trash pieces, misfolded protein aggregates to increase in our cells. There are actually studies that show that intermittent fasting can help with the Alzheimer's disease as well, because it helps clear out even those tangles that are present in the brain. So with this background, let's look at some of the methods. I would have loved to continue discussing the mechanisms. I love mechanisms, but today is intervention day. So first here, new insights into the roles and mechanisms of Spermidine in aging and age-related diseases. The question is, why did I bring in Spermidine here? Coffee can trigger autophagy. Resveratrol can trigger autophagy. Berberine can trigger autophagy. Curcumin can trigger autophagy. Quercetin with zinc can trigger autophagy. There are many factors. Just simple hunger can trigger autophagy. The things that I have here are the most potent and evidence-backed products or interventions. I have no financial relationship with these. But for example, if you have resveratrol, the problem is the bioavailability. Although nowadays the resveratrol's bioavailability with various liposomal and other preparation is improving. Same thing with the curcumin. So if curcumin's availability is low, about 5%, then mixing it with the black pepper or mixing these things with lipid or fatty meals can help improve the availability. The reason I put spermidine over here is this is potent, it is better bioavailable, and it is known to trigger autophagy by bypassing some of the post-translational modifiers. So here, this is 2021, December 1, new insights in the roles and mechanisms of spermidine in aging and age-related diseases. I have marked here, autophagy is the main mechanism of spermidine in delaying aging and prolonging the lifespan. In addition, spermidine exerts its effect through other mechanisms, including anti-inflammation, histone acetylation reduction, lipid metabolism, and regulation of cell growth and signaling pathways. So it has multiple pathways through which it can actually help. So spermidine is an important combination with, for example, intermittent fasting, or by itself as well, or by fasting mimicking diets plus spermidine. So spermidine is one. I wanted to show this to you. All these links are present in the description of this video, so you can more exhaustively look at them. This one, rapamycin. So there are some drugs over here that are prescription only, like metformin, rapamycin, but these are potent autophagy triggers. Rapamycin regulates macrophage activation by inhibiting NLRP3 inflammasomes pathway in autophagy. Nuclear factor kappa B, MAP kinase, and nuclear factor kappa B are really important inflammatory pathways. So if I go down here, rapamycin is the prototypical inhibitor of mechanistic target of rapamycin. Now, remember this protein's name, TOR, is target of rapamycin. So rapamycin is the prototypical one. It is the first one that we found that triggers autophagy. And in the research, when they want to trigger autophagy, they actually give rapamycin. Right? So rapamycin is the prototypical inhibitor of mechanistic target of rapamycin. I called it mammalian target of rapamycin. Some literature further classifies rapamycin mTOR to be mammalian or non-mammalian. So that's why. And inhibits mTOR complex 1. The mTOR complex 1 actively suppresses autophagy by phosphorylating ULK1. So this would be a post-translational modification of ULK1. So what they're saying is essentially that imagine this is the autophagy doing complex. This complex is blocked by ULK1, and then ULK1, it is actually activated by ULK1, but ULK1 is blocked by mTOR, and mTOR in turn is blocked by ample nutritions. Activated by ample nutrition. So when you're fasting, you block this guy, which lifts the block here, which causes ULK1 to do its function. Doesn't matter. The important thing to note over here is rapamycin triggers autophagy. Metformin. Metformin prevents cell tumorigenesis through autophagy-related cell death. So now, please remember, autophagy can be degradative or it can be for survival. Degradative autophagy is when the autophagic mechanisms start eating away at the healthy and the essential components of a cell. And then that cell would die. These kind of things are important. This kind of mechanisms are important to trigger in cancer cells because we want the cancer cells to die. So how do we kill them? We trigger, there are so many mechanisms. For example, natural killer cells would come in and they would throw the perforins and granzymes and kill them. Cytotoxic T cells would come in and they would try to do the same perforin and granzymes. So there are many mechanisms. A hypoxia-inducible factor gets triggered because we try to block the oxygen delivery, etc. Here, metformin can trigger autophagy as well. And to the extent that it can even kill the cell. So if you see here, the analysis of the autophagic markers, LC3 and P62. So when autophagy is going on, there are markers in the blood that you can check to see if autophagy is happening, at least in the research settings. And these are LC3 and P62, for example. The analysis of the autophagic markers, LC3 and P62, confirmed that metformin is able to induce autophagy. In fact, P62 is upregulated after 8 hours and decreased after 24 hours. So these are the details. The important thing to note, metformin. So spermidine, rapamycin, metformin, then the beneficial and adverse effects of autophagic response to caloric restriction and fasting. Intermittent fasting or calorie restriction. I had mentioned this before. I'll mention this again. The point of autophagy in general is not that, hey, cell, go clean yourself. The point of autophagy for the cell is that if there is a stress on the cell, and most important stress is deprivation of nutrition, then the cell scrambles its internal working enzymes to go find energy-making substances within the cell. For that, autophagy is triggered. Autophagy, if there are researchers who are here listening, we are aware that autophagy can be triggered normally, physiologically, to trim away the components of the cell structures. So, for example, imagine the Golgi apparatuses need to be trimmed away. One can activate autophagy. That Golgi apparatus part will become, let me draw this. Imagine Golgi apparatus is a component of the cell. It is a component. So let's say this is Golgi apparatus. And now this is becoming too big for the cell. It's just growing and we don't want it to grow. So a part of the Golgi apparatus will be marked for removal because it has grown too much. And so what would happen is ubiquitination proteins will become, the ubiquitination markers will be applied to a part of this. And then the autophagy Pac-Man would come in and start biting away those parts to kind of trim the component back to the healthy size. So that is a survival and physiological functional autophagy. And we're not talking about that. We're talking about the autophagy that helps with removing the debris. So back here, accumulated evidence suggests that intermittent fasting or caloric restriction can lead to the induction of adaptive autophagy and increased longevity of eukaryotic cells. Eukaryotic cells, the true cells, the cells with the nucleus, our cells, and other animal cells. So any stress actually, not just the intermittent fasting or the nutritional deprivation is the most important one. If somebody has less oxygen, hypoxia, they will get autophagy. If somebody is exercising, and that is a stress on the cell, that would trigger autophagy. If somebody is exposed to a sauna, that would trigger autophagy. If somebody is exposed to cold shock, as the cold therapy, dipping in the cold water, that would trigger autophagy. Any stress on the cell triggers autophagy. So here, accumulated evidence suggests that intermittent fasting or caloric restriction can lead to the induction of adaptive autophagy and increased longevity of eukaryotic cells. However, prolonged caloric restriction with excessive autophagy response is harmful and can stimulate type 2 autophagic cell death. So type 2 autophagy is where the cell would just eat itself. So of course, we will not reach a point of having our cell just eat itself. And we would do 20 autophagy or intermittent fasting that is distributed within 24 hours and not more than that. That is safe for general healthy individuals. Again, everybody has to have a look at their body habitus, their nutrition status, their disease status, and then decide how much. So then, next study, this is 2017 August, autophagy dependent beneficial effects of exercise. Exercise triggers autophagy. Why? Because during the exercise, muscles are continuously stretched and skewed and shaped and misshaped, right? Pulled on, put weight on, increased tone, reduced tone. So that causes the muscle cell to start scrambling to say, all right, man, I need more energy. Do I have something inside of me? And the autophagy gets triggered. So exercise, actually high intensity exercises are just as good for autophagy as intermittent fasting is. And this is why, this is also a very important note that I'm going to make now. Imagine somebody cannot do intermittent fasting for longer periods of time. They can put a little more stress on the cells by doing exercise after fasting for some hours. So combination of exercise and intermittent fasting is actually potent activator of autophagy. But again, within the reasonable limits that you do that, let's say one day, and then the next day you do more normal eating and relaxing. And then the point is to trigger autophagy. The point is not to starve yourself to harm. When you starve yourself one day and then you do exercises with it, you would trigger autophagy that would clean up that day some part of your cell's trash. The next day you can eat normal, balanced and healthy, but you can eat normal. You don't have to keep starving yourself. And then the next day you can starve the cell once more. So we can do it in a healthy way because the point is to remove the trash. And you should keep giving the cell the opportunity to remove the trash, not a continuous opportunity that the cell might end up dying. Opiami says, you need to draw a self-eating cartoon critter. Your drawing skills are good. Sure, will do. So let's see. Lisbeth says, what are typical dosages of spermidine as per the study? So I am hoping that I can go through these studies, and then some of this you can look into, and I can look into that as well a little later. I didn't want to go too deep in any one of them except the mechanism. My apologies. I'll look into that in a second. Autophagy dependent beneficial effects of exercise. So here they talk about adaptations to exercise training. That is, you start exercises slowly, then you build it up. So your body starts expecting that there will be exercise. Your muscles, the stem cells in the muscle would start developing new muscle fibers. The original muscle fibers would start stretching and they would start making new myosins in them. So you don't go tomorrow and do such a strenuous exercise that you come back and you can't even stand anymore. This is what actually happened to me this morning. I went to gym. I felt I could not do the exercise I was doing, but I anyways continued. And my body kept telling me to stop, and I continued. Now for the rest of the day, I have huge pain in my hip and my leg. So just don't bring yourself to that, but slowly bring your body to start adapting and doing autophagy, thinking it's a normal thing. So here they are explaining the autophagy mechanism. Do you see how many proteins are taking part in autophagy? It's not one protein that does it. And this is mitophagy. Autophagy can happen, and mitophagy is where the mitochondria are recycled. That can happen as well. And look at this. This is the autophagosome being built. This is built more. It can even eat mitochondria, and then lysosome will fuse here and it would destroy them. So here, acute exercise-induced autophagy, AMPK pathway. Remember AMP and ATP, mTOR pathway, which we just discussed. FOXO pathway is another one. TFB, P53 is a very important pathway, etc. So exercise, performance, and oxidative capacity, and then the autophagy. Exercise is an important aspect. So imagine if you said, I don't want to take spermidine. You can do intermittent fasting and exercise. And you could do intermittent fasting of not a longer period of time because you have starved yourself a little, your cells a little more by doing exercises and burning a little more of a energy, plus causing some more stress on the cell. Or you said, hey, I don't want to do intermittent fasting. You might want to do exercise with spermidine. Then urolithin A. And I did not know about urolithin A. One of the KoolBeens pointed this out to me. So here it is. Urolithin A activated autophagy, but not mitophagy, protects against ischemic neuronal injury and inhibiting endoplasmic ER stress in vitro and in vivo. So again, this is another one where urolithin A protects against ischemic neuronal injury by reinforcing autophagy rather than mitophagy. So normally when we, sadly, if we get a stroke or ischemic condition of the neurons, mitophagy start, which causes mitochondria to be recycled, which then deprives the cell further and damages them further, the neurons. And here, if the urolithin A is used, it protects from mitophagy and actually encourages autophagy. So that's a good one. Can be combined, let's say, with spermidine. Then here, potential of fasting mimicking diet. And it is interesting that every time I talk about diet, there comes a fight of what kind of diet is right or what is not. Look, it's actually very simple. When somebody is young, you eat whatever you like. I remember in our original language, Urdu language, there is an expression that someone is able to eat wood and stones and digest them as well. Or in our expression here, tolerate them. So what happens is that the discussion here with the diet. Imagine if the cell, somebody is young and they're eating whatever, they're omnivore. They're eating carnivore diet and they're eating lipids and fries and whatever, ice creams and carbs, and they're fine. Once this cell is filled with some trash, now every drop of extra misfolded protein causes a problem. Now you bring that drop with carbs or with proteins or with lipids or with whatever. Eventually the inflammation has to occur and the cell has to be in this shape. And you can fix this by doing plant-based, and that would fix it, or doing carnivore, and that would fix it. The point is to fix this trash. So I don't understand the fight for the food types. It's really, eventually, we are trying to fix the trash or the misfolded protein aggregates. Every kind of restriction will help reduce these. And once you reduce them, you can eat whatever you like. So again, it's there are some belief systems as well, and I'm not talking about that. I'm just talking in general that the food fights are not really the important ones. The fight should be, how do I clear my cells? Because diabetes is a result of 62% of the chronic illnesses are attributable to chronic inflammation. These chronic illnesses include diabetes, cancers, autoimmune diseases, arthritis, allergies, gut problems, cardiovascular problems, hypertension. So one becomes plant-based, they'll feel better because that plant-based diet would help reduce calories, and then they would have the trash moved away. If somebody becomes carnivore, that would help as well, because now they have cut carbohydrates, the high energy packets. So the fight is kind of not, at least in my mind, it's not necessary. The eye should be on clearing the cell, whatever makes you happy to clear them. So here, the potential of fasting mimicking diet. And this paper, I really like it because in this paper, they talk about various food types and they say restricting through any food category or any food habit actually helps with autophagy. So here, this review, so this is the potential of fasting mimicking diet as a preventive and curative strategy for Alzheimer's disease. So really it is fixing the misfolded protein tangles, the tau beta proteins in the brain and neurons. This review examines the potential of fasting mimicking diets in preventing and treating Alzheimer's disease. These diets are low-calorie diets that mimic the physiological and metabolic effects of fasting, including the activation of cellular stress responses, pathways, and autophagy. Recent studies have shown that FMDs can reduce amyloid beta accumulation, tau phosphorylation, and inflammation, as well as improve cognitive function in animal models of AD. I can assure you that if this is more plant-based, if you didn't take plant-based and just became carnivore, even that would do similar thing. Or I can assure you that if you stayed whatever way you are and just stopped carbs, that would do the same thing. So if I go down here for a second, dietary restriction has been demonstrated as a reliable and effective intervention to enhance the longevity and health status of various model organisms. The principal dietary restriction regimens are reported in table and include caloric restriction, intermittent fasting, restriction of specific macronutrients, ketogenic diet, fasting mimicking diet, or plant-based diet. All of them have been shown to reduce metabolic markers associated with aging in both animals and human studies. So can you imagine that what is happening is this, that the cell is filled here to the brim with the tangles, and now somebody comes in and restricts carbs in one way, and somebody restricts the calories or carbs in another way, or somebody puts the stress on the cell in some other way. So 1, 2, 3, and the cell responds. And when the cell responds, they then raise their flag and say, see, we are the best. We have just proven that our mechanism works. Actually, yes, that would work if it is going to help here. And you could help this area by making no changes in your diet and say, I'm not even doing intermittent fasting. I'm going to take Spermidine and do exercises. You could trigger autophagy with that too. So I just wanted to show you this as well. It is worthwhile to read this article because they talk about many dietary types. A dietary protocol, so the fasting mimicking diet, a dietary protocol designed to mimic the effects of a prolonged fast, providing some nutrient intake. The main components of an FMD typically include consuming plant-based foods such as vegetables, nuts, and seeds, and healthy fats like olive oil. But if you see here, they talk about ketogenic diet as well. If you see here, they talk about restricting carbs. They talk about intermittent fasting. They talk about just simple calorie restriction. So all those fights are kind of not necessary. Okay, back here. Moving on. Acute heat exposure. Think sauna, for example. Alters autophagy signaling in myotubes. So here what they did was they took some myotubes, muscle tubes, and they exposed them to various heat temperatures. And then they wanted to see if those muscle tubes, which are really muscle cells, did they start autophagy or not? And they see here that there was a 37 degrees centigrade. And then there was another temperature as well. So there were various temperatures on which they put these tubes and measured them. And I marked over here heat shock proteins. I have done this discussion in the past about the heat shock protein. The heat shock proteins are originally they were found when the researchers had shocked a cell or bunch of cells with heat, and they found some new proteins that came into existence. And that is possible that cell does not keep the things around. So if the heat shock proteins are not needed, then they are not there. And when the cell has stress, then the stress signal goes to the nucleus. The genes would open for the heat shock proteins. Those heat shock proteins would be then formed, and then they would go do their function. Very commonly used or observed is HSP70. HSP70 is also something that is responsible for chaperone-mediated autophagy, chaperone-mediated autophagy, CMA. So when you give a heat shock or a temperature shock, may that be heat or cold, the heat shock proteins become activated, which then start autophagy. So sauna would help. Then here, I want to go to the cold therapy first. Cold exposure protects against medial arterial calcification development via autophagy. So they did this discussion about a specific artery, but autophagy is triggered with cold as well. And then here is something that is interesting for all of us, and that is the autophagic mechanisms become triggered with varying intensities because of our age. And once again, as I said yesterday, that whenever somebody says because of our age, you should challenge that narrative to say, could this be related to inflammation? And the answer is yes, here as well. When what they're saying here is that heat shock does not trigger autophagy with as much intensity in advancer age as it does to younger age. And I hope you know the answer already from the discussion today and yesterday. If the cells are filled with mangled proteins and their DNA repair enzymes were affected as well, then the DNA is probably not functioning as well as it should, which would cause various proteins to not be produced with the optimal design, and they may not function as well as we were in the younger age. Could we reverse that? So that's a big discussion to have, that can the epigenetic changes be reversed? But at least I can say this much, that once we start helping and attacking this problem with multiple interventions so that some pathway gets started, once the autophagy starts and this cell starts becoming cleaned up, inflammation starts reducing, then these cells would behave the same as a healthy cell. So I wanted to quickly share these. Now let's see if I can find the question to Elizabeth's question. Dose milligram. So Elizabeth, I'll have to probably just go over this to see what was their dose, or we'll have to look at it separately. Okay, so I give up because I become blind when I am live as well. So I'll have to look it up separately for the Spermidine dose. So this is the list of things. And if you actually start looking at the literature, there is much more. As I said, coffee can do it, resveratrol can do it, quercetin can do it, many other, methylene blue can do it. These are the ones that are potent and that can be combined. And you might find something else is more potent for you because the autophagy mechanisms and the post-translational proteins are many. So if this pathway is not working, if I can hand wave with my full view, if this pathway is not working, you may be able to sneak in from here. And if this is not working, you may be able to sneak in from here. So when the idea is that, hey, I tried to trigger autophagy and it didn't work with the intermittent fasting, then you may have to go through some other pathway. So this is a discussion. So Guy says that if somebody has a heated helmet, so Guy, there is a near infrared light helmets that are actually used very often by chronic inflammatory disease patients who may have neurological symptoms, and the studies show that they help. I do not know about heated helmet for sure, because what I do not know is the amount of exposure to heat. What I know is that sauna should not be more than 10-15 minutes for the heat shock proteins. And the more you stay in the sauna, then the reverse start the effect starts becoming reverse because protein damage starts occurring. So I think that would be the same principle for heated helmet as well. But I know that near infrared lights and infrared light helmets and face masks are available. Sita says it's exciting that there are so many possible approaches to autophagy. Yes. And Sita, important thing is there may be a need to combine various forces to trigger, to force the autophagy to happen. Nipa says, Doc joined in your Patreon group. Thank you very much. We do 2 Zoom talks on Wednesdays, one at 1 p.m. Pacific and the other at 6 p.m. Pacific. It's a repeat of the same talk, but for people in various time zones. And we do one talk on Tuesday at 5 p.m. Pacific, which is actually for Dr. Bean members, but I include patrons as well. Happy Diwali to you as well. So I hope it was, Dwayne says, helmets are used for hair regrowth. Correct. Life will be better. Thank you, Dr. Bean. You're very welcome. So the mission, if we can have a mission for our life's health, see the idea of exercise is a great mission. Move more, morning walks, infrared light exposures. But I think if I give you the core mission is to check inflammation. Everything else. Yesterday, I was discussing with someone. I sometimes discuss my lectures with some friends and run my structure of a lesson with them sometimes. So yesterday, I was discussing it with someone and they said, how would you take care of the epigenetic changes? And so I concede that epigenetic or DNA mutations could become, can occur because of, for example, these studio lights shining on me are causing DNA breaks. Various chemicals can do it. Various injuries can do that. So there are so many ways that DNA can be damaged that just the reactive oxygen species is not the only mechanism. However, the inability to repair can be because there is, let's say the light is falling, just like, the thunder falls on somebody and they die. If the light fell on a gene that is responsible to make a repair enzyme, then we have a problem for that cell, and that cell might just die. Otherwise, if the cell is healthy and doesn't have all these tangled proteins in it, it will be able to trigger the repair enzymes and the change will be helped. There is another problem with the epigenetic change, and that is that sometimes the cell doesn't have a chance to go over the whole DNA to check every single thing. So sometimes if a gene is damaged, it just leaves it that way. So it is time consuming. Similarly, it is energy consuming to check the whole DNA. So I concede that there can be epigenetic changes that may not be accessible through fixing inflammation. But I would present that with this inflammatory state, we would only aggravate the situation. So imagine if the normal epigenetic changes that are out of inflammation's hand would age us that we live up to 130 or 40. Inflammation then adds further damage and more epigenetic changes that bring our age and health down towards 90 and 100, an unhealthy state. So anything that you see, the first thing to look at is inflammation. Paul says, thank you for making this easier to understand. You're very welcome. I was afraid that I'll go too much in depth with the autophagy mechanism, but I saw that one diagram that was just mTOR, autophagosome, done. So I just stayed there. I have done actually a detailed discussion that is on YouTube where I went through the whole weeds of autophagy mechanism. Marcy says, excellent talk and really good to know about more ways to trigger autophagy. Thank you. You're very welcome. And I'll keep repeating, not to offend anyone, to combine ways. If you see my autophagy talks on the other channel, you would see that many times people write underneath, I tried it didn't work. They may need to have another additional force applied as well. John says, great chit chat. Thank you. You're very welcome. Les says, thanks so much. Good reinforcement of many discrete things we can incorporate to reduce inflammation and improve our health and well-being. Absolutely. Absolutely. Dwayne says so many options to try. Absolutely. Absolutely. And these are just some. These are just, I was looking for the most potent and most evidence-based. Otherwise, there are a list of things. The question is, for me, it was impossible to go through that whole list of more than 100 possibilities to then sort out which one is really true and which one is just somebody trying to sell you something. So I just took the one that was most evidence-based. So absolutely. So Jean says, do cold showers trigger autophagy? Yes. Anytime your cell is under stress. Do you know there is one stress that does not trigger autophagy? That is when you are under stress, psychological stress, that releases cortisol, or when you are under stress, for example, such strenuous exercise that caused cortisol release, or intermittent fasting so prolonged that released cortisol. When the cortisol is in the field, then autophagy will start turning off. And so cold showers are a very tolerable stress that we can take. There's a study which I have linked in the description as well, which showed that with the intermittent fasting, the cortisol levels start rising up, and within 6 days, they rise up to 25 to 30%. So one can simply counter that by doing intermittent fasting on alternate days. I like Jason Fung's way as well, that fasting, but dinner is still there. So really, there is no true fasting there. Dinner is there, and then the breakfast and the lunch and the dinner, and then actually 2 meals the next day, and then 1 meal. So still pretty tolerable. Mike Ma says, astaxanthin also for autophagy. Agreed. And I have to talk about that. I have to read up first. Marcy says, happy to hear that dear Luffy is doing much better. Yes. So tomorrow he has 8 o'clock. He has a doctor's appointment. Let's see what happens. But generally, when I look at his abscess, it's fine. Thank you very much. So if we combine yesterday's talk with today's talk, then it becomes an explanation of the mechanisms with the possibility of helping that situation with your doctor's advice. Any other OPME says, dude, doctor is not too in depth. It's lucid and great content. Sita says, thanks for sorting them out for us. You're very welcome. Sigrid says, thank you, Dr. Bean. More tools in that tool chest. Absolutely. Mike Ma says, great pair of talks. Thank you. So, yes, I don't know. I feel I understand the situation with the doctors, and I also feel bad for the patients. Their situation, doctor's situation, is they just don't have enough time to go read up. When they do read up, they go for the conferences for the CMEs, and there they read up whatever is being taught over there. And these are more selective topics that are for general consumption and aligned with the mainstream medicine. These studies are really important for patients' sake, but not necessarily everybody has time to do that. So that's why I'm doing it and presenting it to you. So with this, thank you very much. Have a nice weekend, and I would see you next week. Bye for now.